Hello. So yesterday I discussed about complex number. I have introduced complex number and discussed what is modulus and amplitude of a complex number. Now today I discuss some problems related with modulus and especially amplitude, which is tough to understand, especially amplitude, very tough to understand. So a little discussion on modulus, but a large discussion on amplitude or argument. So let's start. Like first problem I am taking that a expression is given minus iota 1 plus iota. We have to find out both modulus and amplitude of this expression. How can we express find out the modulus and amplitude of this expression? Here, one thing you can note that here numerator is also consist of complex number and the denominator is also consist of the complex number. So this cannot be expressed in this form z equal to x plus iota y. If here the denominator is equal to 1, so we have to find out in any way the denominator must be, it cannot be a complex number. So let's see, if we take this is z equal to minus iota by 1 plus iota. So how we can transform this complex number into a real number? So we have now understand what is conjugate of a complex number. Conjugate of a complex number. Actually, the meaning of conjugate is that it transforms any complex number into a real number. This is the meaning of conjugate. But there can be two type of conjugates. I am discussing two type of conjugates here can be like 1 plus I is the denominator. So we can take first type minus 1 plus iota, and second is 1 minus iota. If we multiply with the conjugate with this complex number, then what we'll find out? First multiply first type of first type of complex number, and we will get 1 plus iota, and this will be iota minus 1, which will be I square minus 1. This will be minus 2. Iota square is equal to minus 1. So it you can look that this transforms the complex number into a real number. There is not any complex number. And if you use the second type, then what will be 1 plus iota and 1 minus iota. Then it will be 1 minus iota square. Iota square is equal to minus 1, so it will be plus 2. So the both can transform the complex number into real number. So we in the complex study of complex number just take second type of complex number as conjugate. This is called conjugate. And the imaginary part, the iota, is taken the opposite side. Here is positive, it is taken negative. If it is negative, then it will be taken positive. So this is called conjugate. The real part we cannot take opposite side, but the imaginary part we have to take negative side. Now here we multiply with the conjugate, the numerator and denominator, but it will be minus iota 1 minus iota 1 plus iota 1 minus iota. So this will be, we have found out that this will be equal to 2. So we write here 2, and here it will be minus iota plus iota square. It will be minus iota, my iota square is equal to minus 1, minus 1. So we will transform in this form x plus iota y. This will be minus half plus minus half again, and iota minus half. So now it is expressed in this form x plus I1. Now we have we can find out modulus. So mod z is equal to what? Mod z is equal to root over x square plus y square. This is the modulus of z. So here modulus of z will be mod z is equal to root over minus half whole square plus minus half whole square. So if we simplify this, this will be 1 by 4 plus 1 by 4. And if we add up 1 by 4 and 1 by 4, this will be 1 root over 1 by 2. And that we will get 1 by root 2. So this is the modulus of the complex number. And the important thing is that now we have to find out the amplitude. So amplitude depends on the where the point exists on the complex plan. If we draw the complex plan, this is the real axis, this is the imaginary axis. Here you can find out that negative negative, both x and y negative. So the point exists on the third quadrant. So there z is z belongs to the third quadrant. If we take to the origin, the line join, this is the modulus of z. Now we have to find out this angle theta in clockwise direction. This is the clockwise direction. So it must be minus theta. Minus should be taken for the clockwise direction. So how we can take this? If we take it alpha, that we have to take pi minus alpha. This is pi. So minus theta will be equal to minus pi minus alpha. Minus just sign just showing that it is clockwise direction taken. It is taken in clockwise direction. So this minus theta will be minus pi minus alpha. And alpha can be very easily calculated. It will be tan inverse y by x. This is y, this is x. The alpha is equal to tan inverse y by x. Modulus sign we can put here because we have considered already negative sign taking the complex number in the third quadrant. We can put here modulus of y by x. So now amplitude of z can be found out. amplitude of z is equal to minus theta, which will be minus pi minus alpha, which will be minus pi plus alpha. Alpha is tan inverse mod of y by x. So minus pi remains, and tan inverse y by x will be tan inverse y by x. So both are half half. So it will be 1. Both are half half. So this will be 1. So minus pi plus tan inverse 1. Tan inverse 1 over 10, which value gives 10 tangent function to 1? Pi by 2. So sorry, pi by 4. So this will be minus pi plus pi by 4. So it will be equal to minus 3 pi by 4. So in this way, this angle is 3 pi by 4. This angle is 3 pi by 4. This is 3 pi by 4. And negative sign shows that it is taken in clockwise direction. So in this way, amplitude can be calculated. Take another example. So another problem. Let's see. Given 1 minus iota plus 3 minus 4 iota. So again we have to use conjugate of the denominator. So if we'll take this is z, then what will be the conjugate of 3 minus 4 iota? Just an imaginary part is negative, so we have to take positive, and we will multiply with this. So 1 minus iota 3 plus 4 iota 3 minus 4 iota here 3 plus 4 iota. This will be equal to here it will be 3 square minus 4 iota square, and the numerator will be 3 minus 3 iota plus 4 iota minus 4 iota square. This is equal to 3. Here the calculation is that plus iota, and here iota square is equal to minus 1, so this will be plus 4, and here this will be e square 9, and iota square gives -1, this will be +1, and 4 square is 16. So we will have 7 plus iota by 25. So you can write down it 7 by 25 plus 1 by 25 iota. So find the modulus amplitude. Find. Then I will do. I write down the answer. Try to find out. Try. Class question. So we have not sent anyone the answer. So I am doing this. Again, we will have to find out the modulus. So mod of z, modulus of z, written as mod z, which will be root over x square plus y square. So what is x and what is y? It can be written down in this way: x plus iota y. So x is equal to 7 upon 25. This will be 7 upon 25 whole square plus, and there is 1 upon 25 y. This will be 1 upon 25 whole square. So if we add this will be root over 49 by 625 plus this will be 1 by 625. This will be 3 upon 625. 605 root over of 625 is 25, and here we can break this. This will be 2 by 25. 2 by 25. Just taking the multiple of 25, and this is root over 2 by 25. This is root over 2 by 5. So this is our modulus. And what is the amplitude? To calculate the amplitude very easy here, because you can do this all the x and y both are positive. So in the complex plan, the number z belongs to the first quadrant. Z belongs to the first quadrant. So here amplitude is very easy to find out. Amplitude z is equal to simply tan inverse y by x. You can take modulus or not, it does not matter. So here amplitude of z is equal to tan inverse y is 1 by 25, 1 upon 25, and x is 7 upon 25. So this will be tan inverse 1 by 1 upon 7. This is our amplitude. Now let's know what is the modulus amplitude form. Important one. Let's another topic. What is the modulus amplitude form? Is equal to, we are taking this is r, this will be root over x square plus y square, and amplitude of z is, we are taking theta, then it will be tan inverse y by x. What we will get from here, that x square plus y square. Keep it this. So from this we will get that tan theta is equal to y by x. And now we can write down this. So draw that figure. It can easy to understand. If there is z, this is y, this is x, this is r equal to root over x square plus y square. So here this is a real axis, this is a imaginary axis. This is theta amplitude of z. So by trigonometry we know that uh, x by r is equal to cos theta, and so x will be r cos theta and y by r is equal to sin theta. So y is equal to r sin theta. Now if we put here this value, then z transform into modulus amplitude form. It will be x is equal to r cos theta and y is equal to r sin theta. And so r cos theta plus iota r sin theta. Take r common, then it will be r into cos of theta plus iota sin theta. So this is the modulus amplitude form. Here just we have to know the r, the modulus of z, modulus of the complex number, and the theta, the amplitude of the z. This is the amplitude modulus amplitude form. Now let an example how any complex number can be transformed into modulus amplitude form. Take an example. An example we are taking, this is given that root 3 minus iota by 1 minus iota root 3. So we are taking, this is z, and we have to, this is the normal form. We have to form transform this into amplitude, modulus amplitude form. So how we can do this? What we will do, we will find out the conjugate of it and multiply both numerator and denominator. Then it will be 3 minus iota. Its conjugate is just 1 plus iota root 3. 1 plus iota root 3. And this will be 1 minus iota root 3 and this is 1 plus iota root 3. So this will be equal to root 3 minus iota plus iota root 3, and here it will be minus iota square root 3, and here it will be 1 whole square minus iota root 3 whole square. So this will be root 3 and here it will be plus iota root 3 minus 1. Here iota square is equal to minus 1. This will be plus root 3 and here it will be 1. Iota square minus 1 minus 1 minus 1 plus 1 and this will be 3. We are getting 2 root 3 plus iota root 3 minus 1 by 4. So we can write down here this will be equal to root 3 by 2 minus plus iota root 3 minus 1 by 4. This will be 3. There is not will be root over. This will be 3. So this will be 3 minus 1. This will be 2. This will be 2. This will be 2. This will be iota 2 or 2 iota. So this will be 1 by 2 iota 1 by 2. So this is now the normal form. Now we will transform it to modulus amplitude form. How we can do this? We have to find the modulus and the amplitude of this complex number z, this form. So what will be modulus z r? R is equal to here root over x is equal to root 3 by 2. This will be root 3 by 2 whole square plus y whole square. This will be 1 by 2 whole square. This will be equal to root over 3 by 4 and here it will be again 1 by 4. So if we add this will be 4 by 4 root over 1, this will be 1. And what will be the theta? So we have to find out theta, amplitude of z, amplitude of z. This will be theta equal to 10 inverse. You can find out that both are positive, so this complex number must belong to the first quadrant of the complex plan. First quadrant, so this will be 10 inverse y by x. So half by y by x root 3 by 2. This will be tan inverse 1 by root 3. So what value of tangent gives us 1 by root 3? This is just pi by 6. Pi by 6. Now we can very easily get the modulus amplitude form. So modulus amplitude form, the required modulus amplitude form that can be written down. R is R cos theta plus iota sin theta. If we put these values, we have found R is equal to 1. This is 1 into cos of theta is equal to pi by 6 plus iota sin pi by 6. So we cannot find out these values. We will get return back to the value of this. So we keep it in this form. This is the modulus amplitude form. So this is our required form. So now we will prove two relations on argument that first relation on argument, very important relation, is that argument of the amplitude of two complex number on multiplication relation z1 multiply z2 is equal to argument of z1 plus argument of z2. It is a relation proved based on geometrical properties. We'll just test that this is true or not. Is it true? This relation is true. Is it true or not? So take an example. Take z1, any complex number. This is given 1 plus 3 iota or iota root 3 and z2 take root 3 minus iota. So first we have to find out the multiplication of z1 and z2. This will be z1 multiply z2 is equal to 1 plus iota root 3 into root 3 minus iota. So this is equal to 3 plus this will be 3 iota minus iota and there will be minus iota square root 3. again we will have, this will be plus root 3, this will be 2 3, and here we will get 2 iota. This is our multiplication form of the two complex number z1 z2. Now its argument will be argument of z1 z2 multiply z2 will be, you can find out that this lies on the first quadrant, both are positive, so we will take simply tan inverse y by x, y is 2 and x is 2 root 3. This will be tan inverse z2 lies in the fourth quadrant, here z2 lies. So what is how we can measure the amplitude theta? You have to take in the clockwise direction negative of theta. So this will be minus tan inverse mod of modulus of